Okay, perfect. So this is an internal presentation for i2cat about the project ITER. So it's just like the slides that we prepare here. Um, the idea is to explain a bit about what was the project, what was the architecture that we wanted to deploy there, and the internal developments, that it was about satellite flexible payloads and how to integrate OSM in the main orchestrator for non-terrestrial networks. Then a bit of the technologies and the dissemination products that we have there. So first, a bit of context is an European project. It involves around 12 partners and is general is to develop the technology about 6G in the integration from the non-terrestrial networks, especially satellite and aviation. It was divided in four packages. The idea is that it was focusing the radio access network, in the orchestration of the network itself, integration of artificial intelligence, and the integration of the flexible payload in the satellite. A lot of tasks that I put to dig deeper. Well, the main idea is that this is the 3D architecture. We're going to integrate the ground segment, the aerial segment, and the satellite segment in this general orchestrator, this unified orchestrator. And we can deploy any service from 3G on all these layers. And to do this, we are going to implement the Ether Mano, that is the XC Mano modified for aerial and space, and with a lot of small parts for artificial intelligence in different segments, so we can increase the usability and the performance of the network. The project was actually finished like 2 months ago, and we are now trying to do the close of the project. We present three use cases, sorry. And the main use case is the one I'm going to present today, that is about how to use Ether in the IoT delay tolerant networks. And for that one, we use OSM and the deployment of container-based cellular network on the satellites. So first about the flexible payload is technology that we're developing in i2cat about dividing the satellite in 3 layers. The first layer is about the hardware. So the idea is that we can reconfigure the hardware of the payload of the satellite to offer any specific service. And we can, for example, change the radio frequency or provide hardware accelerator services for anything that we can deploy in the satellite. Then is the layer of the software, so we can reconfigure the software of the satellite or update the service or provide different services because it's going to be a virtualization layer that we can deploy either containers or virtual machines. And on top is the service layer or the orchestrator layer. That is where we are using OSM as a main orchestrator to deploy all of these software and hardware services. Here is a bit of the reconfiguration. We can skip this. And here is how we are implementing specifically the orchestrator. So this one is the HCNFB architectural framework. We mainly introduce 3 new components. The main component that is more interesting for OSM is the GIS layer, that is a geographical information system inside the OSM. So we can explore more graphical the geolocalization of nodes, either ground or in space. And also we can provide this geographical awareness for the services. So we can deploy any service on a specific target area that we can select from a map. It's like we have a infrastructure that we know that by the name is Barcelona, and we know going to deploy Barcelona. We can have a real map and say that we want to deploy a specific service in this city. Then is the satellite mobility manager that is integrated inside Kubernetes. So since OSM is already integrated with Kubernetes, is transparent there. This component is used to transmit the information from the geographical information system to the satellite. So the satellite know where is the position of the satellite, where is the position of the service, and they can match this information to provide a service in a specific target area. And then we are going to deploy this still on development phases from my thesis project. The first stage is that we're going to deploy Kubernetes in each satellite. So all the virtual infrastructure, it could be multiple satellites working independently as single nodes. The second stage is that we can combine all together in a unified cluster, and we can control everything from a single point of view. And to do this, we are also going to deploy the device plugin that is a way to control from Kubernetes the flexibility of the hardware, and we can provide this reconfiguration from the mano through the satellite, just with this unified architecture. Here is a bit how we can integrate a bit better the deployment of the services from a satellite. So we have on the ground segment, the OSM and the GIS tool. We have the Helm repositories to provide the images of the services that we want to deploy. And here is an algorithm that we developed internally, how to deploy these images from ground segment to the satellite through a TTC. TTC is the telemetry and terminal commands link. This is normally a VHF. It's a really slow link with a lot of problems, so we have to be really mindful with the size of the images. So the idea here is that we are going to send small chunks, have the compromise that the image is okay. So there is a specific protocol here to transmit the image and reload in the satellite. And after that, we only transmit the network service descriptor. That is only one configuration file to the Kubernetes internally, and is going to be managed internally from Kubernetes. Yeah, that's all from here, I guess. From the OSM part, so here is what we were working most related with OSM. So we integrate the Postgres database with the PostGIS plugin. So now with this plugin, we can integrate the geographical awareness in the database, and we can geolocalize different points. Also inside the all the namespace of OSM, we are deploying GeoServer. GeoServer is this engine that allows us to connect with the database and provide graphical information, graphical maps that we can visualize in different systems. And on top of that, we create this is a graphical interface that is actually a plugin from the browser. So we didn't integrate anything directly in the graphical interface of OSM. It's just a plugin that we can deploy side by side in either OSM or any other orchestrator. But it is that they connect with this GIS service, and we can create different layers to visualize different things that we want in the map. For example, here we integrate the weather, so we can see the clouds or precipitation. That is important for the satellites to know if it's going to be any problem with the communication link. And also we can integrate different ground information, like in this case is Earth stations, but it could be also the normal data centers that we are going to deploy, or well, any information that we want to plug in a map. The main quality of this that is that we can draw a region. So we can select any piece in the map that we are going to deploy a service, and this is going to translate this information from this polygon as coordinates that they can be interpreted with the trajectory of the satellite. So they encode this in the descriptor as timestamps where they have to start the service and when they have to stop the service. That is related when the satellite is entering into the target area and going out of the target area. So in this way, we control that the service is going to be activated when it is required, not all the time that the satellite is flying around the Earth. That's all from the OSM. Then is the general configuration of the OSM with the beam, that is in this case Kubernetes. So we are going to integrate all the rest of the components that again is the dummy beam, and from the dummy beam connected to Kubernetes. And here is a bit of the protocol that we create to upload the images. It's just taking the chunks of the information from the manifest, the OC images from the container. We read which images are actually on the satellite, based on a registry that is mirroring this container registry on the satellite, and we just select by hand. Let's say, well, the ground agent, the algorithm, just select by cherry pick the images, that the chunks that we need because they are not already in the satellite. They compress everything in intervals, and we send one by one depending of the bandwidth that we have in the satellite communication, the satellite link. And then on top of the satellite, they compile again all the information, and they combine as a normal image, and they push this image inside the registry that is already in the satellite. Or every time that we want to deploy something, is consulting the internal registry, and they deploy everything, any service that when is required for Kubernetes. The demo that we create is you was here in i2cat. We created with the simulation of 2 satellites with the boards, the development boards. In this case, is the ZSU from Xilinx. And we have 2 Amarisov emulating the InnoV, and then 2 user equipments that are with the Raspberry Pi and the module to connect with the LTE technology. This is to provide the reconfiguration of the satellites, and we've been simulating the orbit of the satellite. And with the use of OSM, we create different target areas that we wanted to deploy the service and activate or deactivate the service depending on this trajectory of the satellite. Here is one of the applications that we had about the measurement of the radio frequency scanner with FFT and the configuration of the hardware. Well, this one is a flexible payload. Here is more related with the how we activate the different services. So again, the operator just draw the target area that they want. They select one of the satellites that is already like the dummy beam. We just name the satellite, the dummy beam, with the same name of the satellite, so the plugin can read which satellite we are going to deploy, and it only interpolates this orbit with the target area, and it sends the information to the satellite when it's going to be active or not. So here there is no activation because there is no other service, only the Redis that it was part of the flexible payload, and it's not activated because it's not in the target area. And then here, when it's inside the target area, we can see that there are more services deployed. That it means that it was activated inside the target area. So this is more or less how it was working. Here there is the web page of the project and one of the demos, the explanation of the demo, that they have more story, and they have more detailed what was expressed about all the project and how it was working. So basically here is here we develop, we activate the plugin, we only draw the target area that we want. We transform that in the configuration, the extra configuration from the help. Basically, it's only the start and end timers, and what is the service that we want to deploy, and all the definition of the network service that we want to deploy. Then we deploy that on the satellite. We assume that we have the contact window. Then since it's already inside Kubernetes, Kubernetes is in charge of activate or deactivate everything according to these orbits. Here we can see that it's just switching between internal services, and at the end, when it leaves the target area, finally switch to other different services that it was planned. That's all the summary of the project. I don't know if you have any questions so far.